Hey there, and welcome. Ever look at a spreadsheet and just feel lost? Like you're drowning in a sea of numbers? Well, you're not alone. We're surrounded by data. But the real trick is turning all that noise into a clear signal. And that's exactly what we're going to do today. Find the actual story that's hiding inside the numbers.
Take a look at this. What even is this? It's just a jumble of raw numbers. On its own, it's completely overwhelming. And, let's be honest, pretty meaningless. It doesn't tell us a thing. It's just chaos.
So that brings us to the million-dollar question, right? How on earth do we take this mess of digits and turn it into something we can actually understand? Something that tells us a story? Well, luckily, there's an amazing tool built for exactly this job.
So, let's meet the hero of our story, the frequency histogram. And I want to be clear, this is not your average everyday bar chart. Oh no, this thing is a specialist, an expert tool designed for one purpose, to bring order to that data chaos.
All right, so what is this thing really? Well, you can think of it as a special kind of bar chart that takes all those numbers and sorts them into groups. But its real job, its whole purpose, is to pull back the curtain and show us the pattern, the secret shape that's been hiding in there the whole time. So how does it work? Well, the idea is actually pretty simple. First, you group all the data into different buckets, or bins as they're called. Then you just count. You count how many data points fall into each bucket. That count, the how many, is your frequency, and that goes on the vertical axis. The buckets themselves go along the bottom. Then you just draw the bars, and that's when the story starts to take shape.
And this, my friends, is where the magic really happens. See, a histogram isn't just about making things look neat and tidy. By organizing the data this way, it actually reveals something, well, kind of profound about the data itself.
Check this out. All of a sudden, that random list of numbers has a structure. For the first time, we can actually see where most of the values are bunched up and where they're not. This is so much better, right? But believe it or not, the best part is still to come.
Okay, now this is the real aha moment. Imagine just sketching a smooth curve right over the tops of these bars. You see that? By connecting the dots, you reveal the data's hidden shape. And that shape has a very important name.
That shape is called the distribution, and this is the big takeaway, folks. That shape, that is the story. It's the narrative that was hiding in plain sight in those raw numbers all along. The histogram is just the tool that finally lets us read it. You know, it's kind of like looking at a city skyline. Each building is like a bar in the histogram. But what you really remember, what you see, is the overall silhouette of the city against the sky. That silhouette, that's your distribution.
And just like city skylines can be spiky or flat or have a couple of really tall towers, data distributions have common shapes too. It turns out that most of the time, data tends to tell one of a handful of classic stories. So let's take a quick tour of the 5 most common shapes you're going to run into.
Okay, so here's our lineup. We've got the famous normal distribution, or bell curve. Then there's the flat uniform distribution. We have 2 lopsided shapes, skewed left and skewed right. And finally, the 2-humped bimodal distribution. Each one tells a totally different story. First up, the big one. You've definitely heard of this one. It's the famous bell curve, or normal distribution. It's perfectly symmetrical, with most of the data packed right in the middle, and it gently tapers off on both sides. You see this shape absolutely everywhere in nature. All right, next up we have the uniform distribution. This one is super easy to spot, because basically every outcome has the same chance of happening. The bars are all roughly the same height, which gives it this flat, kind of rectangular look. A perfect example is rolling a single fair die. Every number from 1 to 6 has an equal shot. Okay, now for the lopsided ones, the skewed distributions. The best way to think about these is like a kid's slide. If the long tail of the data slides down to the left, we say it's skewed left. If the tail slides down to the right, it's skewed right. And here's a great way to remember it. It's skewed where it's light. In other words, just look for where the short bars are, that's the direction of the skew.
And last but not least, we have the bimodal distribution. This one's another easy one. It literally looks like a camel with 2 humps. And whenever you see this, it should be a huge red flag, a good red flag, that you've probably got 2 totally different groups mixed together in your data. Think about a restaurant's busy hours. You'd see a peak at lunchtime and another big peak at dinner. 2 humps, bimodal.
But sometimes the story has a plot twist. Sometimes there are characters in our data that just don't fit in with the main crowd.
And in the world of statistics, we call these plot twists outliers. So what's an outlier? It's just a value that is so far out there, so different from everything else, that it makes you stop and go, huh, that's weird. And guess what? Histograms make spotting them ridiculously easy.
Yeah, when you look at a histogram, an outlier just screams at you. It shows up as this lonely little bar way off to the side, separated from the main group by a big empty space. It's like a giant flashing sign that says, hey, look at me, I'm different.
Okay, so we've wrangled our data, we've found its shape, we've even spotted the weirdos. But so what? Why did we do all this work? I mean, who cares if it looks like a bell or a camel? Why does the shape really matter?
It matters because that shape, that distribution, is basically a roadmap. It tells you exactly what you can, and more importantly, what you can't do next with your data. See, a ton of the most common statistical tests out there only work correctly if your data has that normal bell curve shape. If you try to use them on skewed or bimodal data, you're just going to get garbage results. So finding the shape isn't just a neat party trick. It is the absolute critical first step to doing any kind of meaningful analysis.
So from now on, whenever you're faced with a wall of numbers, I want you to stop. Don't just see the chaos. Instead, build the histogram, find the shape, and ask yourself, what story is hiding in my data?